Good morning, my YouTube viewers. Crystal here. What I wanted to do is I wanted to show you my scores on this competition that I entered for customer segmentation. You see that the first competition the first thing that I did using the standard model that I've been using for the past few days, I had a 58%, which wasn't very good. And then I did a few things, which I tuned my XGB parameters, and that increased the score a little bit by fine tuning the XGB parameters. And then what I did was I segmented the age to try to improve my score. So I got my score up to close to 66%. And then I segmented my work experience and I got that score up to 67%. So I'm just showing you what I did. And this was my position on the leaderboard. I know it's not very high. The highest position was 95%, but definitely I was able to improve it, by, 9 points, close to 9 points, just by fine tuning XGB, the XG boost, and segmenting age and segmenting work experience. And I would have had to have done a lot more work to get the score higher than what I got it. But since it's not an active competition, I'm not going to worry about it. And I just wanted to review the code with you. Now I put my code on GitHub, so you can look at my code on GitHub because it's public, and you can go along with me on GitHub if you like. But basically, I imported my libraries. Probably imported a lot more than I need, but I always do. And then I loaded up my files. So this is the train file. So you can see what the train file looks like. And there were a few NADA numbers. Check the info of the train file, and you can see that there were quite a few objects and quite a few NADA numbers. Check I described the train file, so you can see a description of the train file. Looked at the test, checked the info of the test file. You can see there's quite a few objects and quite a few not a number characters. And so what I did was I put some code in for the train file and the test file to see where there were missing values. And so this tells you on the train file and the test file the columns that had missing values. And so what I did was I used code to replace the null values with using the mold function. And what that does is that just takes the middle value, and then the codes that were numbers, I replaced it with the median function. So I used the mode function and the median function to replace these columns. So now you can see the train file and the test file where the not a number values have been replaced. The next thing I did was I removed unnecessary characters in the var1 file. So now the var1 file is just a number instead of a string. I did that to the test file as well. And so now what I'm doing is I'm checking the different columns in the file to see what's going on with them. So basically what had happened was on the segmentation was not a number, it was letters. But that's going to be dealt with at some point. So we checked genders. And so you can see that we grouped the column by gender. And then you can see the percentage of male and the percentage of female. And so I set up bins where female was 0 and male was 1. And I set that up. I set that And then basically, now what we're going to do is check to see if a person's married. And if I had wanted to, I could have put in another chart to see if they were married, but I didn't do that. Probably should have done that, but I didn't. And then I set up a dictionary where no is 0 and yes is 1, and I replaced the values with 0 and 1. I checked the ages. I grouped ages to segmentation. And now we have a little violin chart on the ages, so you can see the maximum ages was around 40. And then what we did was we plotted another chart, and this was a chart that somebody else did, and I just used it for my purposes. And you can see a bar chart of the ages of the customers as well. And 26 to 35 is slightly larger than more than anybody else. So I created bins, and I had to look that up on the internet to figure out how to do that. But I created bins, and then I created a new column called age range. And then I did a group by with the age range, and the group by set it up so rather than having like 80 different ages, you just had 5 different age ranges. So then I created a dictionary of the age ranges, and each age range was assigned a number. And then I tested to see if the train file and the test file had any null characters. And during this process of transposing the information, you've got some null characters. So then what we did was we filled the null characters with the mode value, which is the center value. And then what I did was I dropped the age column because you didn't need the age column anymore. We tested for graduates to see if they were graduates, and then so I set up a dictionary. If they weren't a graduate, it was 0. If they were a graduate, it was 1. Then I grouped their profession, so you can see all the different professions that were in the column, and we set up a dictionary and assigned each profession a number, and we mapped that column with the profession. The next thing we did was we checked work experience, and so the work experience had 14 values, so that meant they could have 14 years of experience. I plotted a little violin chart. The most work experience was in the 1-year range, and then the 9-year range. So I created some bins, created the work experience, and created a new column called work range, and I put every year of the work experience went into one of those segments, went into one of those categories. And then I created a dictionary of the work range, and each work range was assigned a number, and each work range in the column had a number assigned to it. So I checked to see if there were any null characters, and yes, during the process of changing over, during the process of transforming the data, we've got a bunch of null characters. So what I did was I replaced the null characters with the mode value, which is just simply the center value in the column. So I dropped the work experience column, so that's not needed anymore. Then I tested their spending score, and I made a dictionary of low, average, and high, and I assigned each a low, average, and high to a number, so that column now has a number on it. So we did a graph of the spending score, and you can see number one, the most of the people were in the low spending range. Then we did a box plot so you can see how the spending score relates to the age, and another box plot how the spending score relates to the family size. So then we did a group of the family size. So I suppose if I had wanted to, I could have made a small, medium, and large family. So a small family would be 2 people. A medium family would be 3 to 5 people, and a large family would be 6 and over. I suppose I could have done that, small, medium, and large, and that may have improved my score a little bit more. So we did a violin graph of the family size, and then we did another plot of family size and spending score as well. We checked Var 1 of family size, and then this is your segmentation. So what I had to do was, because the segmentation was in characters, I had to assign each character a number. So now you can see the test file, you can see the test file, and here you can see the train file. And here you can see information on the train file, and you can see there are no null characters, but the last 2, age range and work range, are categories. And you can see the test file, there are no null characters, but you have 2 categories. So what we did was we converted var 1 to numeric, and we had to do errors equals coerce. So now you can see that var 1 is now a numeric value, whereas before it had been an object, because when you are dealing with numeric values, they all have to be numeric. And then I made you a little heat map if you like heat maps. So now I prepared the data so we can set up our features. And we set up X and X test. Wanted to see Y, I wanted to see X, and I wanted to see X test. So we split our data into a training set and a testing set, and we used the standard scaler to get all of the values on the same range. We set our model as XGB classifier, and the name was XGB. We used K-fold, stratified K-fold, to help with classification, and we checked our CV results, and we checked our accuracy was 52, and it tends to stay at that value. I don't know why. We set up our model, we fit our model, we made predictions on our model, and then we had our output file. But what we had to do was we had to, on our output file, because our output file was actually in numbers, because you can see here it was in numbers, we had to convert the numbers back to characters. So we had a dictionary called Seg2 where each number was a character, and you can see that it's given each number a character. And then we sent our submission file to the output. So that was it. So that concludes this code review. I do think I'm going to go back to family size and see if I can improve my score by setting up segments in the family size as well. You know, every little bit helps. If you like my video, please like, subscribe, and share. Please let me know what you think of my video. If you like the work I do and want to leave a donation, I've got my email address for my PayPal account down below, because I don't have enough subscribers to monetize my videos. And thank you so much for watching this video, and I look forward to you seeing the next one.